Hello guys, welcome to In 5 Minutes. In this slide we will see shift register. Now see, shift registers has got very wide application in the industry, and how they works we will see in this presentation. So there are various types of shift registers, as majorly they consist of SISO, that is nothing but serial in, serial out. The data is serially in and serially it is out of the register. Second one, you'll see serial in, parallel out. Third one, parallel in, serial out. And the very fourth one is PIPO, that is nothing but parallel in, parallel out. Means what? Let us say there's a 4-bit register. Okay, so what do I have here is, let us say there are 4 compartments. Okay, these are nothing but bits or the location where we store the data, in which data input is here. So this one is the input, output for first condition, that is nothing but serial in, serial out. So what will happen, data input for each coming clock pulse, all these locations, location number 1, 2, 3, 4 or the registers, they will shift their place. Now serial in, serial out for the very first combination, what will have here, serially data first clock cycle, that will come here, then it will jump to the second one, from the next third clock cycle it will go to third place, for the fourth clock pulse it will jump to the fourth, and for the very fifth clock pulse data will be serially out. Means what? If your data is input at the first clock cycle, you have to wait till fifth clock cycle come, then the data is out serially. Or you can take data parallelly out in this manner. Okay, that is nothing but serial in, parallel out. Or you can send the data parallelly in. So this one is the case for parallel in, parallel input, P input, and you can take it serially output, parallel in, serial out, or parallel in, parallel out. So these are the forms. Now where you can use this shift register in industry, as we will look the exact shift register step by step, SISO, SIPO, PISO and PIPO. So these are the shift register. Moving out to very first shift register, that is nothing but SISO. So what we have here, serial in, serial out. Now what we have here, as I told you earlier also, we are going to shift the data and we are not going to change the data. That's why we are going to use here D flip-flop. So D flip-flop A, D flip-flop B, D flip-flop and D flip-flop D. So there are 4 flip-flops A, B, C, D having inputs, data inputs DA to D. So this is going to be the final input. Data is input at DA, which will be serially shifted, because we know that it's a D flip-flop, so it will just delay the input to the output. There is no change in data. So whatever the data present at A will be shifted to B for each coming clock pulses. At the same time, you'll see we are using synchronous register. That means each clock pulse is given simultaneously to each flip-flop. That's why they all will shift the data for each clock pulse. As A output is given as an input to B, B will shift its whatever data present to C, and similarly at the same time C will shift it to D, and D will be the final output. So you can observe the output at D place. So what we can do here is simply at D put a resistor and a diode in series and ground it, so you will be able to see what is the data received. So this is the current limiting resistor R connected to QD.